Chapter 5, Example 5.28. Dear viewers, we are taking only important exercise and examples for your board exam. The questions in our videos are very important. Confidently you can focus these questions. Definitely you will get these type of questions or these the same questions or this type of similar questions definitely will appear in the board exams. So you need not worry. So in our videos the questions are very important only we have chosen. So you can do the other sums also, but give more and more priority. Complete these type of problems first. The questions which are in our video should be given priority first. Then you can go to other problems because these are the questions repeatedly taken in our boards. So those type of questions only I am working in our videos, and then if I get time we will work remaining video questions also. Now chapter 5, example 5.28. Given that a line making positive intercept with the coordinate axis means x and y axis for like this way. This is x axis and another one is y axis. It makes only positive intercept, means it meets x and y axis in the positive side, that is positive intercept. Let it be the intercept be a, x intercept be a, that is distance from origin to the point A is a, and this is taken as b, and this length is b. And then sum of the intercepts, the length of the sum between a and b, sum of these two values a plus b equal to 7 is given, and then the line the line passes through the point minus 3, 8 is also given. The line passes through minus 3, 8. So the minus 3, 8 is somewhere in the second quadrant. It may be here. We can take minus 3, take here, it will be 8 here, minus 3, 8 somewhere here. And then find such a line, the equation of line. We should find the equation of this line. This is very easy. Given intercept form, given intercept, so first you write the formula for intercept form of line. So intercept form of line is is x by a plus y by b equal to 1, where x and y are a and b are x and y intercepts. X by a plus y by b equal to 1. Given sum of intercepts is 7, that is a plus b equal to 7. A is x intercept, b is y intercept, sum of the intercepts is 7, therefore a plus b equal to 7. From this we can conclude answer b equal to 7 minus a, or you can find a equal to 7 minus b. Substitute 7 minus a for b in the above equation, will get x by a plus y by 7 minus a equal to 1. Now cross multiply here. 7 minus a into x plus ay divided by a into 7 minus a equal to 1, which implies 7 minus a into x plus ay equal to a into 7 minus a. Now multiply inside. 7a minus a square, 7 minus a into x plus ay equal to 7a minus a square. Let it be equation number 1. Given that the required line passes through minus 3, 8, so substitute minus 3, 8 in place of x and y in the equation number 1. Substitute minus 3 for x is equal to minus 3 and y equal to 8. Therefore 1 implies it passes through minus 3, 8. Therefore 1 implies, substituting in 1 for x minus 3 and for y 8. So 7 minus a into minus 3 plus ay a into y is 8. So 8a equal to 7a minus a square equal to 7a minus a square. Now multiply this minus inside. Minus 21 plus 3a plus 8a equal to 7a minus a square. Grouping one side, a square minus a square on the left side plus a square. We have 3a plus 8a, that is 11a, and then this plus a on the left side minus 7a. We have minus 21 equal to 0. Now simplifying this, a square plus 4a minus 21 equal to 0. Factor it. When we multiply minus 21, when we multiply we will get minus 21. When we add, answer will be equal to 4. There are two numbers, they are 7 minus 3. When we multiply you will get minus 21. When we add you will get 4. So these are the factors. A plus 7 into a minus 3 equal to 0, which implies a plus 7 equal to 0 and a equal to minus 7, and a minus 3 equal to 0, which implies a equal to 3. Given only positive intercepts, so we can omit this minus 7 and we can take a equal to 3 only, because the intercepts only for positive. So the positive intercept a is chosen and minus 7 is left out. Now substituting a equal to 3 in equation number 1. Now 1 implies substituting in 1, a equal to 3, 1 implies, substitute here, a equal to 3, 7 minus 3 equal to 4, that is 4x, and then here a equal to 3, that is 3y, and then substituting 3 here, or substitute here a into 7 minus a, or you can substitute here a into 7 into 3, 21, minus 3 square, 9, which is equal to 21 minus 9. Substituting a equal to 3, 7 into 3, 21, minus a square is 9, minus 9. That is equal to 4x plus 3y, 21 minus 9 is 12, taking left side, minus 12 equal to 0. This is our required answer. Look at here, after finding the positive intercept, substitute that a equal to 3 in this equation, you can directly get the equation of the required line. Substituting a equal to 3, 7 minus 3, 4x, that is 4x, and a equal to 3, 3y, and then here 7 into 3, 21, minus a square 9, 21 minus 9 is 12, taken left side minus 12, 4x plus 3y minus 12 equal to 0. Exercise 5.4, question number 4. This is very important question. Repeatedly it has given in the board, and the same question appears in 11th standard also. Look here, you can learn one question of 11th standard in 10th standard. Right, find the value of P. The two lines are perpendicular. Perpendicular means intersect at right angle. Both lines intersect at right angles. So okay, first convert this line into proper form, standard form. That is, standard form is ax plus by plus c is equal to 0. a1x, b1y, c1 equal to 0, and here a2x plus b2y plus c2 equal to 0. Convert the equation in the standard form. That is, bring it left side. P plus 3 into x, because we have negative quotient, taken left it is positive. And here we have plus 12y. ax plus by, then the constant term plus 12 on the left side, minus 12 equal to 0. It is very easy, convert in this way. And then the second line, a2x 12x minus 7y minus 16 equal to 0. That's all. This is very easy. Now we have a condition to intersect perpendicularly, or that is, two lines are perpendicular, then a1 a2 plus b1 b2 equal to 0. Coefficient of the first line into second line plus coefficient of coefficient of x of the first line into second line and coefficient of y of the first line and second line will be equal to 0, sum of these two values. So this is a1, another one is a2, and then here is b1, b2, which is a1, this is a1, here b1, a2, b2. Take the coefficients here. Now a1 is p plus 3 into a2 is 12 plus b1 is 12 into b2 is minus 7 equal to 0. Now both has 12, so divide it by 12. That is very easy. When divided by 12, these two terms eliminate, then p plus 3 minus 7 equal to 0. Are you clear? Dividing by 12 both the terms, these 12 and 12 get cancelled. Remaining is p plus 3 and then plus into minus 7 remains. Now p minus 4 equal to 0, which implies the value of p equal to 4. It will be asked in 5 mark. You can go this way, that is very easy. One another form is also can apply, that is you can find slope of first one and slope of second one. If the lines are perpendicular, product of the slopes is equal to minus 1. If you go in this way, it will be bigger than this method. So choose this method for this particular problem. The two lines are at right angle or perpendicular. The product of the coefficients of x plus product of the coefficients of y will be equal to sum of the two equal to 0. Sum of the product of the coefficients of x and the product of the coefficients of y, the corresponding lines will be equal to 0. So taking a1, a2, b1, b2 and substituting in this, we will get the value as p equal to 4. Very simple thing. Question number 7 in exercise 5.4. Given vertices of the triangle are A, B, C. A, B, C are the vertices of triangle. Let it be A of minus 3, 4, B of 10, minus 2 and C of 12, 3. Approximately I plotted the point here. That is a rough sketch. Now we need to find the equation of altitudes through A and B. Equation of altitudes through A and B. That is, let it be the altitude AD and one another as B. What does mean altitude? The line drawn perpendicular to one side of a triangle from the opposite vertex. Line drawn perpendicular to one side of a triangle from the opposite vertex. That AD is one altitude and B is another one, drawn from B to the side AC. So AD and BE are the altitudes. Now we should find these two equations, equation of AD and equation of BE. So to find equation of AD, look at here. It passes through minus 3, 0. So there is a point we have. We have a point. The altitude passes through A. Therefore, the point is minus 3, 0. We have one point. And we need a slope of this AD. Slope of AD is nothing but AD is perpendicular to BC. So slope of AD will be equal to perpendicular slope of BC. Perpendicular slope of BC. So slope of AD will be equal to perpendicular, because AD is perpendicular to BC. So both slopes are perpendicular. So find slope of BC and then find the perpendicular slope of BC. That will be slope of AD. So to find the slope, we have formula m equal to y2 minus y1 by x2 minus x1 when the 2 points are known. Now here slope of BC equal to m equal to, slope of BC is taken as m. Slope of BC is m. Slope of BC is equal to m. That is y2 minus y1. Write the formula y2 minus y1 by x2 minus x1. and then the perpendicular slope of AD is nothing but its reciprocate and change its sign. So slope of or perpendicular slope of BC, that is slope of AD, perpendicular slope of BC is equal to minus of x2 minus x1 by y2 minus y1. Just reciprocal and change its sign. That is enough. So the perpendicular slope of BC will be equal to, substituting here, minus B and C are taken. B is 10 comma minus 2 and C is 12 comma 3. This is x1 y1 and x2 y2. Substituting x2 minus x1, 12 minus 10, that is 2. Here x1 y1 and this one is x2 y2, because we are calculating slope, perpendicular slope of BC. So x2 minus x1, 12 minus 10 is minus 2. Sorry, 12 minus 10, 12 minus is here. Then 12 x2 minus x1, 12 minus 10 is 2. The minus presents here. Then divided by y2 minus y1. 3 minus of minus 2, that is plus 2. 3 plus 2, that is 5. This is the perpendicular slope of BC. This is equal to slope of AD. Therefore, slope of AD is nothing but slope of AD equal to perpendicular slope of BC. So both are equal. We can take this one as minus 2 by 5. This is taken as M here. Now, the required equation of AD, equation of altitude through A means that is AD. Equation of altitude AD is, it passes through a point, it has a slope m equal to minus 2 by 5, y minus y1 equal to m into x minus x1. Now substituting, the point is taken as x1 y1, a is minus 3 comma 0, that is x1 comma y1, and m is the above value minus 2 by 5. Calculating, y minus y1 is 0, m minus 2 by 5 into x minus x1, that is x minus x1 means x plus 3. Now cross multiply this 5, 5y equal to, multiply minus 2 inside, minus 2x minus 6. Now bringing to left side, 2x plus 5y plus 6 is equal to 0 is the equation of altitude AD. And now we should find the equation of one another altitude, that is BE. To find BE, equation of BE is calculated here, is nothing but slope of B equal to perpendicular slope of AC. So slope of BE, I can write here, slope of BE equal to perpendicular slope of AC or CA, AC. Right. Now slope of AC, perpendicular slope of AC. Slope of AC is nothing but, slope of AC is equal to y2 minus y1 by x2 minus x1. So x1 y1 x2 y2 are x1 y1 equal to, taken A as x1 y1 minus 3 comma 0 and x2 y2 equal to, that is C, 12 comma 3. Slope of AC is this one and perpendicular slope, it's a perpendicular slope. Perpendicular slope of AC is nothing but reciprocal and change its sign, minus of x2 minus x1 by y2 minus y1. Substituting in it, minus, then x2 minus x1, x2 minus x1, 12 minus of minus 3, that is 15 divided by x2 minus x1, 12 minus of minus 3 plus 15 divided by y2 minus y1, y2 minus 1, 3 minus 0, that is 3. We can cancel that. Therefore, perpendicular slope of AC, that will be equal to slope of BE. So, perpendicular slope of AC is equal to minus 5. Cancelling, we will get minus 5. Now, the slope of B is equal to perpendicular slope of AC. Both are equal. So, now m equal to, take it as m, slope of B is taken as m, that m equal to minus 5. Now, equation of altitude BE is, we can apply the same formula, x minus x1, y minus y1 equal to m into x minus x1. Here A is taken as, because we should find the equation of altitude through B, passes through B, so B is taken as x1 comma y1, B of 10 comma minus 2 equal to x1 comma y1. Now substituting the above equation, for x1 y1 10 minus 2 and for m minus 5, here y minus of minus 2 equal to m into minus 5 into x minus 10. Simplifying, y plus 2 equal to minus 5x plus 50. Bring it to left side. 5x plus y plus 2 minus 50 equal to 0. Therefore, simplifying, we have 5x plus y minus 48 equal to 0. 5x plus y minus 48 equal to 0. This is the required answer. These type of problems are very, very important for your board. So, practice well these typical problems. Eighth question in the same exercise 5.4. Find the equation of bisector of the line joining the points of A of minus 4 comma 2 and B of 6 comma minus 4. Perpendicular bisector, that is very important, given here equation of perpendicular bisector. For example, let A and B are the points here and there, and joining A and B we have line AB, and the perpendicular bisector means it is perpendicular to the line AB, and bisector means it must passes through the midpoint of AB, that is taken as M. So the perpendicular bisector, equation of perpendicular bisector is nothing but it passes through the midpoint of AB and perpendicular to the slope of the line AB. So we should find two things here. One, M equal to midpoint of AB, because the bisector passes through midpoint of AB, and perpendicular slope of AB, because the slope, perpendicular bisector slope is perpendicular to AB. So perpendicular slope of AB, that is taken as M, and the midpoint of AB is taken as x1 comma y1. By use of these two, by applying the formula y minus y1 equal to m into x minus x1, we can conclude the required value. So midpoint of m equal to midpoint of AB, m equal to midpoint of AB, that is equal to, the midpoint formula is A and B are is given as minus 4 comma 2. This is a rough diagram, not an exact one. So AB midpoint minus 4 plus 6, minus 4 plus 6 by 2 comma 2 minus 4 by 2. So M is equal to 2 by 2 comma minus 2 by 2. 2 by 2 comma minus 2 by 2. Therefore, which is equal to 1 comma minus 1. This is taken as x1 comma y1. The required point M is x1 comma y1. x1 and y1 applied here. And we need M value. M is nothing but perpendicular slope of AB. So find slope of AB. Slope of AB equal to y2 minus y1 by x2 minus x1. And perpendicular slope of AB equal to minus of x2 minus x1 by y2 minus y1. by use of the points A and B. A is minus 4 2, B is 6 comma minus 4. This is x1 y1, here it is taken as x2 y2. Substituting in here, minus x2 minus x1, x2 minus x1, 6 minus of minus 4, 6 minus of minus 4 divided by y2 minus y1, minus 4 minus 2, that is equal to minus of 6 plus 4 by minus 6, that is 10 by minus 6. These two get cancelled, the plus 10 by 6. So therefore required perpendicular slope of AB m equal to 10 by 6, that is equal to 5 by 3 by cancelling 2. So the required equation is equation of perpendicular bisector is y minus y1 equal to m into x minus x1. So y minus y1, for here x1 y1 are the value m, so m is taken as x1 comma y1, m of x1 comma y1 equal to 1 comma minus 1. While calculating slope value, this is x1 y1, this is x2 y2. When we find the perpendicular bisector, the point m is taken as x1 y1, that is we found here. So applying that one here, we'll have, which implies y minus of minus 1 equal to m into m value is 5 by 3 into x minus x1, x minus the x1 value is 1. So cross y minus of minus 1 equal to 5 by 3 into x minus 1. The multiply here, y plus 1 equal to 5 by 3 into x minus 1. Now cross multiplies is 3. 3y plus 3 equal to, the multiply 5 inside, 5x minus 5. Now simplifying, we have x positive on the right side, so bring the left side terms to right side. We have 5x minus 3y. Already we have minus 5 on the right side, so plus 3 on the right side is minus 3 equal to 0. So bringing all the term on side, we have 5x minus 3y minus 8 equal to 0. So 5x minus 3y minus 8 equal to 0 is the required equation of the perpendicular bisector. Question 9, exercise 5.4. Given, find the equation of line which passes through the point of intersection of these two lines and parallel to the line 13x plus 5y plus 12 equal to 0. That is, let it be equation 1 and it be equation number 2. Now these are the two lines intersected at a point P. This is line 1 and line 2. Now this is the point of intersection x1 comma y1, and we should find the line passes through the point of intersection of the lines. This is our required line. This is we want to find. It passes through the point of intersection of these two lines and also parallel to one line, that is 13x plus 5y plus 12 equal to 0. Our required line passes through intersection of these two lines and parallel to the required line 13x plus 5y plus 12 equal to 0. So we should find such a line. So first of all we should find the intersection point, then we can calculate the remaining. How to find the intersection of two lines? So to find point of intersection, solve these two equations 1 and 2. So how to solve here? Multiply the first equation by 5 and second equation by 7, or multiply the first equation by 4 and second equation by 3, equate the coefficient of y, or in the first method equating coefficient of x or equating coefficient of y in the both equations. So now multiply the first equation by 5 and second equation by 7. So 1 into 5 implies, first equation multiplied by 5 here. So 35x plus 15y equal to 50. And then multiply second equation by 7. Second by 7, which implies 35x minus 28y equal to 7. Now we have equal coefficients, they are equal sign, so change its sign. All the terms, if you say change sign, all the terms, that is cancelling these two get subtracted 0. Now here 15 plus 28 3, and then 43y equal to 43, which implies y equal to 43 by 43 equal to 1. Now substitute y equal to 1 in any of the equation, either 1 or 2. Substitute in 1. Substitute y equal to 1 in 1. Equation number 1 will have 7x plus 3 into 1. Y equal to 1 means 3 into 1 3 equal to 10. 7x is equal to 10 minus 3. 7x is equal to 7, which implies x is equal to 1. Therefore, the point of intersection P of xn comma y1 is equal to 1 comma 1. So, P of x1 comma y1 is equal to 1 comma 1. And the required line is parallel to the given line. The parallel lines differs only by constant. Therefore, equation of required line equal to required line parallel to 13x plus 5y plus 12 equal to 0. Therefore, required equation is in the form of 13x plus 5y plus k equal to 0. These two are parallel, so I only differ by constant. So replacing this 12 as different constant k will get the parallel form of this line. Now it passes through the point 1 comma 1, substitute in it at 1 comma 1. 13 into 1 13, 5 into 1 5 plus k equal to 0. Therefore k equal to 13 plus 5 18, k equal to minus 18. Now substituting k equal to minus 18 in the above equation. So the required equation is 13x plus 5y equal to minus 18, or 13x plus 5y plus 18 equal to 0. Question number 10. The required line passes through the intersection of these two lines and perpendicular to the line 4x minus 7y plus 13 equal to 0. Similar to the question number 9, but a small change. Passes through the intersection of two lines and parallel to the given line in question number 9. But here perpendicular to the given line. How to find the perpendicular form of a line? For line AX plus BY plus C is equal to 0 is given. To find its perpendicular form, interchange the coefficients of x and y, that is bx ay, and change the sign of y and apply a constant term k equal to 0. Now this line is perpendicular to the above line. The perpendicular form is find by the above method. Interchange the coefficients of x and y and change the sign of y and place a new constant. You will get a perpendicular form of a line. Now here find the intersection of, that is there are two lines 1 and 2, let it be 1, another one is 2 here. 1 and 2 intersecting at some point P of x1 comma y1. That will be found by solving the equations 1 and 2 by elimination method or substitution any of the method. And then the line is perpendicular to the line. Now we are keeping this line here, 4x minus 7y plus 13 equal to 0. Now the required line is passes through the intersection and perpendicular to, passes through this point and perpendicular to the line. This is our required line. It passes through the intersection and perpendicular to this line that we have to we want to find. So first of all, we should find the intersection point by solving the equations 1 and 2. Now multiply 1 by 3 and 2 by equation 5. 1 into 3 implies, multiply by 3, 15x minus 18y equal to 6, and equation 2 by 5, which implies 15x plus 10y equal to 50. Now subtract, will get minus minus minus, here get cancel, remaining is minus 28y, here minus 50 16, minus 50 plus 6 equal to minus 44. So y equal to 44 by 28, both side we have minus sign, so get cancelled, that is equal to by dividing by 11 4 we have 11 fours are 48, here 7 fours are 28, y equal to 11 by 7. Now substituting y equal to 11 by 7 in equation number either 1 or in 2, substitute in 1, will get 5 into x minus 6 into 11 by 7 equal to 2, which implies 5x minus 66 by 7 equal to 2, which implies 5x is equal to 2 plus 66 by 7, negative on the right side, positive. So 5x is equal to 14 plus 66 by 7, that is equal to 80 by 7. So 5x is equal to 80 by 7, x is equal to 80 by 7 into 5. We can cancel this for 16 times equal to x, which implies x is equal to 16 by 7. So the point x1 comma y1 or x comma y, x1 comma y1, the point of intersection is 16 by 7 comma 11 by 7. Now if I find the point x1 comma y1, we have found the point x1 y1 16 by 7 comma 11 by 7. Now we should go to find the equation of this line. Now this is perpendicular to 4x minus 7y plus 13. So the perpendicular form of 4x minus 7y plus 13 is perpendicular form of 4x minus 7y plus 13 equal to 0 is, interchange the coefficients 7x and 4y, change the sign of y, here minus it is changed as plus, and introduce a constant k equal to 0. Now substitute at, it passes through 16 by 7 comma 11 by 7 at substituting in it 16 by 7 comma 11 by 7, which implies 7 into 16 by 7 plus 4 into 11 by 7 equal to plus k equal to 0. Now calculating the value of k, 7 into 16, 70, 42, 112 divided by 7, and then plus 44 by 7 plus k equal to 0. Now adding these two values, 156 divided by 7 plus k equal to 0. Now is it divisible by 7 here. Now substituting this k value, which implies k equal to minus 156 by 7. Substituting minus 156 by 7 in the equation number 3, we have 3 implies, equation 3 implies 7x plus 4y, then minus 156 by 7 equal to 0, multiply by 7, 49x plus 28y minus 156 is equal to 0 is the required equation of the line, which is passes through the intersection of these two lines and perpendicular to the line 4x minus 7y plus 13 equal to 0. Question number 11. Given question is find the equation of line which passes through the point of intersection of the first two line and the point of intersection of the second two lines. Let the lines be 1, 2, 3, 4. Now this will be the point of intersection of line 1 and 2, and then this will be the equation of the line 3 and 4. They are all intersecting at P1 and these two intersect at P2. Now our required line passes through P1 and P2. We should find the equation of line. This is our required line. That is, our required line passes through the point of intersection of first two and the next two lines. So solve 1 and 2, you will get a point that is P1, and solve 3 and 4, you will get a point, one more point, that is P2, and then use 2-point formula, y minus y1 by y2 minus equal to x minus x1 by x2 minus x1 to find the equation required equation. Now solving 1, 2 and 3, let it be 1, another one is 2, here is equation 3 and we have equation 4. Now these two are not in proper form, we arrange it. Now first one, multiply 1 into 1, which implies 3x plus y equal to, so we can take it as minus 2 equal to 0, 3x plus y equal to minus 2. Now that is 1 into 1, 3x plus y equal to minus 2. Now the equation 2 by our equation 2 is rearranged as x minus 2y equal to 4. This is equation 2. Now multiply second equation by 3. 2 into 3 implies 3x minus 6y equal to 12. Now subtracting, we have cancelling here 7y equal to minus 14, which implies y equal to minus 14 by 7 equal to minus 2. Now substitute y equal to minus 2 in equation number 1. We get 3x, y is minus 2 equal to minus 2. Now 3x is equal to minus 2 plus 2 equal to 0. Now 3x is equal to 0 implies x is equal to 0 by 3 equal to 0. Therefore the point P1 is x1 comma y1 0 comma y is minus 2. Similar to that, solve 3 and 4, find P2. So 3 is in proper form, 4 is, can arrange 4 as x minus 2y equal to minus 3. This is equation number 4. Now multiply keep the third equation as same, 3 into 1, there is no change in it, 7x minus 3y equal to minus 12, and multiply the fourth equation by 7, we will get 7x minus 14y equal to minus 21. Now subtracting, we have minus plus and cancel these two. 14 minus 3 is 11y equal to, here we have plus sign, 21 minus 12 is equal to plus 9. So 11y equal to 9, which implies y equal to 9 by 11. Therefore the point of intersection, so we found y. Now here substitute y in any of the equation 3 or 4, find x. Substitute y equal to 9 by 11 in equation number, which is easy to you, in 3 we have 7x minus 3 into 9 by 11 equal to minus 12, or you can go with equation number 4, that is easy comparatively with 3. So equation number 4, substituting in 4, here x minus 2 into 9 by 11 equal to minus 3. Now x minus 18 by 11 equal to minus 3. X is equal to minus 3 plus 18 by 11. Taking LCM, x is equal to minus 33 plus 18 by 11. Now x is equal to 7 minus 15 by 11. Therefore point P2 is The point P2 is minus 15 by 11 comma 9 by 11. Now we should find the equation of the line joining P1 and P2 by use of 2-point formula. We have found points P1 and P2. P1 is 0 comma minus 2 and P2 is minus 15 by 11 comma 9 by 11. By use of these two, we can find the required line by using the formula y minus y1 by y2 minus y1 equal to x minus x1 by x2 minus x1. So x1 comma y1, P1 of x1 comma y1 is equal to 0 comma minus 2 and P2 of x2 comma y2 equal to, the second point is taken here, that is minus 15 comma 11, 15 by 11 comma 9 by 11, and substituting the formula y minus y1 by y2 minus y1 equal to x minus x1 by x2 minus x1. Here we are substitute here. This is x1 y1, x2 y2, y minus y1. y1 is minus 2, they have taken as plus 2. y minus of minus 1, y plus 2 by y2 minus y1. 9 by 11 plus 2 equal to x minus x1 is 0 by x2 minus x1 minus 15 by 11 minus 0. Now simplify this. We'll have y plus 2 by y plus 2 divided by y plus 2 divided by, taking LCM, 22 plus 9, 31 by 11, which is equal to x by minus 15 by 11. Here this denominators and the numerator, 11 into y plus 2 divided by 31 equal to 11x by minus 15. Now we can cancel these 11. Now cross multiplying, we have minus 15y minus 30 equal to 31x. Now regrouping, 31x minus 15 on the right side plus 15y minus 30 on the right side plus 30 equal to 0 is the required equation of the line that passes through the points P1 and P2. P1 and P2 are the points of intersection of the line 1 and 2 and 3 and 4.